Space exploration has always represented humanity's greatest achievement and most dangerous endeavor. We've sent brave explorers beyond the protective embrace of Earth's atmosphere, into an environment so hostile that the human body can only survive for minutes without specialized equipment. Throughout the decades of spaceflight, we've encountered events so disturbing that they've fundamentally challenged our understanding of what it means to push the boundaries of human capability. Today, we're going to explore the most unsettling and tragic moments that have occurred in the vast darkness above us. The earliest warning sign came on January 27, 1967, when the world learned about the Apollo 1 fire. Inside the cramped cabin of the command module, astronauts Gus Grissom, Ed White, and Roger Chaffee were conducting a plugs-out test at Launch Complex 34. The spacecraft was pressurized with pure oxygen, which made it extraordinarily flammable. During the test, a spark ignited somewhere in the tangled wiring beneath the instrument panel, and the fire spread with terrifying speed. The astronauts couldn't escape. The hatch design meant they needed approximately 90 seconds to open it, but the flames consumed the cabin in seconds. All 3 men died in the inferno. The investigation revealed that NASA had known about potential fire hazards, but hadn't adequately addressed them. This tragedy forced a complete redesign of the spacecraft and led to significant changes in safety protocols, but it came at the highest possible cost. Then came one of the most mysterious disappearances in space history. On April 5, 1975, the Soviet Union launched Soyuz 7A toward the Salyut space station. Cosmonaut Vladimir Komarov was aboard the spacecraft. Komarov was an experienced spaceman, but this mission would be his last. His spacecraft experienced critical malfunctions during re-entry. The parachute system failed catastrophically. The capsule plummeted toward Earth at terminal velocity, and there was absolutely nothing mission control could do. When recovery teams found the capsule in the wreckage of a crash site, they discovered that the force of impact had been so violent that Komarov's remains were almost entirely cremated. The investigation later revealed that engineers had warned about the parachute design flaws, but the missions had been rushed due to political pressure from the Soviet government. The Soviet space program would face another devastating loss in 1971. 3 cosmonauts, Georgy Dobrovolsky, Vladislav Volkov, and Oleg Patsayev, were returning from Salyut 1, the first space station ever occupied. They had spent nearly 24 days in orbit conducting experiments and making repairs. As their Soyuz capsule descended through the atmosphere, something went terribly wrong. At an altitude of around 104 kilometers, a valve in the capsule opened unexpectedly, causing all the air inside to rush out into the vacuum of space. The 3 men lost consciousness within seconds and were dead before the capsule even landed. Recovery teams found the men still strapped into their seats, their bodies showing signs of exposure to the vacuum. This tragedy led to the requirement that all Soviet cosmonauts wear spacesuits during launch and re-entry procedures. In 1986, the Soviet Union launched Mir, their ambitious space station. Mir would operate for 15 years and serve as the primary focus of Soviet and later Russian spaceflight. However, the station experienced numerous mechanical failures, fires, and collisions. One of the most disturbing incidents occurred on February 19, 1987, when a fire broke out in the Quant module. Cosmonaut Vladimir Solovyev and flight engineer Viktor Afanasyev had to fight the blaze while dealing with thick smoke and limited visibility. They managed to extinguish the fire, but the incident highlighted how vulnerable astronauts were in the confined spaces of spacecraft. Another catastrophic event happened on June 25, 1997, when a Progress cargo vehicle collided with Mir during a docking attempt. The collision punched a hole in the Spectra module, and the station began losing atmosphere. The cosmonauts had to quickly seal the module and depressurize sections of the station. They worked in near-total darkness as they struggled to prevent complete decompression. The Space Shuttle program gave America its own tragic chapter in space history. On January 28, 1986, the Space Shuttle Challenger lifted off from Kennedy Space Center on mission STS-25. The mission was scheduled to last for 6 days. Among the crew was Krista McAuliffe, a teacher from New Hampshire who had been selected to conduct experiments in space. The world watched as the shuttle climbed through the sky, 73 seconds after launch, something catastrophic happened. A seal in one of the solid rocket boosters had failed due to the unusually cold launch temperature. Hot gases began leaking past the seal, and over the next 84 seconds, the structural integrity of the external tank was progressively compromised. The shuttle broke apart during flight, and all 7 crew members were killed. It was the worst accident in the history of the Space Shuttle program, but the tragedy didn't end there. On February 1, 2003, the Space Shuttle Columbia was returning from a 16-day mission to the International Space Station. During launch, a piece of foam insulation had broken loose from the external tank and struck the left wing of the shuttle. The impact created a hole in the wing's heat-resistant tiles, but nobody knew it had happened. As the shuttle re-entered the atmosphere, hot gases penetrated that hole, slowly melting the internal structures of the wing. The crew was unaware of any problem. Alarms began sounding in the cabin as the shuttle experienced increasing vibrations. Mission Control lost telemetry from the spacecraft, and within minutes, Columbia broke apart over Texas, killing all 7 crew members aboard. Beyond these crude disasters, there have been countless disturbing events in the uncrewed exploration of space. The vacuum of space is infinitely more hostile than any environment on Earth. Uncrewed spacecraft have encountered radiation storms that have destroyed sensitive electronics, micrometeorite impacts that have punctured hulls, and solar events that have rendered spacecraft inoperable. The Phobos missions, a Soviet attempt to land on the Martian moon Phobos in 1988 and 1989, both mysteriously failed. The first mission lost contact, and the second experienced a complete systems failure just as it was approaching its destination. The exact causes of these failures remain unknown. Then there's the issue of decompression and exposure to vacuum. This is one of the most disturbing aspects of spaceflight, because it's something that could happen to any astronaut or cosmonaut at any time. If a spacecraft were to lose pressure suddenly, the human body would be exposed to an environment that's approximately 1/1000th the atmospheric pressure at sea level. Unprotected humans would lose consciousness within seconds. The water in their eyes, mouth, and on their skin would evaporate. Their lungs would rupture from the pressure differential. It would be an extraordinarily agonizing way to die. There have been near misses throughout history where spacecraft came dangerously close to experiencing catastrophic depressurization. Each incident has been a stark reminder of how fragile the human body truly is in space. One particularly disturbing incident occurred during the Skylab program in 1973. Shortly after Skylab's launch, it became clear that the micrometeorite shield had been ripped away during ascent, exposing the station to intense solar radiation. The station began heating up dangerously, and it looked like the entire mission might be a failure. However, the Skylab 1 crew, Pete Conrad, Joseph Kerwin, and Paul Weitz, performed a daring spacewalk where they deployed a makeshift sunshade to reduce the interior temperature. The spacewalk was incredibly dangerous. They were working in the intense heat and radiation, with limited time and resources. Any mistake could have been fatal. They succeeded, but just barely. The incident demonstrated how quickly things could spiral out of control in space. The issue of long-term exposure to radiation in space is another deeply disturbing aspect of spaceflight. Beyond Earth's protective magnetic field, astronauts are exposed to high-energy cosmic rays and solar radiation. Over extended missions, this exposure can increase the risk of cancer, cataracts, central nervous system damage, and other serious health conditions. During the Apollo missions to the Moon, astronauts had to pass through the Van Allen radiation belts, intense regions of trapped radiation surrounding Earth. The exposure was brief but intense. Long-term missions to Mars or beyond would expose astronauts to radiation levels that could cause severe health problems and potentially fatal conditions. Another deeply troubling event in space history involves the loss of spacecraft and crew without any clear explanation. The Challenger disaster and the Columbia disaster were eventually explained, but other incidents remain mysterious. The Soviet Union launched numerous spacecraft, and not all of them are accounted for. Some missions experienced failures that were never publicly disclosed. There's evidence that several cosmonauts died during the early space race in ways that were covered up by the Soviet government. The exact number of casualties during the Soviet space program may never be fully known. There's also the disturbing reality of what happens to the human body in microgravity over extended periods. Astronauts experience bone density loss at a rate of about 1% per month, which is similar to the rate of bone loss in postmenopausal women. Their muscles atrophy, their cardiovascular system becomes deconditioned, their immune system is suppressed. Upon returning to Earth, it can take months or even years to fully recover. Some long-duration spaceflight veterans have experienced permanent health problems. The human body simply didn't evolve to spend extended periods in microgravity, and we're still learning about the long-term consequences. The psychological toll of spaceflight is another disturbing aspect that's often overlooked. Astronauts and cosmonauts experience extreme isolation, confinement, and separation from everything familiar. They're living in a tiny spacecraft where they can't go outside, and if something goes wrong, rescue is impossible or would take months. The stress and anxiety associated with this environment can lead to psychological problems. There have been incidents where astronauts experienced panic attacks or emotional crises in space. The mental health challenges of long-duration spaceflight are a serious concern for future deep space exploration. One of the most disturbing aspects of early spaceflight was the lack of medical support. If an astronaut or cosmonaut became ill or injured in space, there was very little that could be done. The first spacewalk, performed by Soviet cosmonaut Alexei Leonov in 1965, was filled with unexpected dangers. His spacesuit inflated more than expected due to the pressure differential between the inside and outside of the suit. He couldn't fit back through the airlock. In a moment of desperation, he vented some of the air from his suit, which allowed him to squeeze back through the opening. He survived, but the incident could easily have been fatal. The problem of micrometeorite impacts is another deeply disturbing reality of space. Spacecraft travel at extremely high velocities, around 17,500 miles per hour in low Earth orbit. At these speeds, even a tiny piece of debris becomes a deadly projectile. A speck of paint traveling at orbital velocity can penetrate an aluminum plate. Micrometeorites, bits of rock and dust floating in space, pose a constant threat. Spacecraft are designed with shielding to protect against these impacts, but the shielding isn't perfect. Over time, numerous small impacts can accumulate and weaken the structure of the spacecraft. There have been instances where micrometeorite strikes have damaged critical systems on the International Space Station. The launch and re-entry phases of spaceflight are the most dangerous times. During launch, a spacecraft must accelerate to orbital velocity while ascending through the atmosphere. The stresses and vibrations are intense.